We're continuing with day 16 part 2. I would expect this part to be somewhat challenging. To recap part 1, we had hexadecimal input, simply a simple string, one line long string that contained different packages. Here we have some sample hexadecimal input, and we needed to do a few operations. We needed to first, let me see what is my main function. We needed to read it from a file. After that, we needed to parse it from hex to binary with a specific structure. After that, we needed to count some prefix. This prefix here, that was this number actually, that was containing the version number for each package, and we were simply summing up the all of the versions of the packages that were in our hexadecimal input. However, we weren't parsing the packages more than that, and now I would assume that we'll need to get more involved, because our packages were two types of packages. If you have watched our video, you will know that we have a package that is literal value, that it's like a number, and we have other packages with different ID, type ID. The one that it's a literal, it's type ID 4, and we have some others like a 1, 6, and their certain operation. And now I would assume that we will need to evaluate these operations. Let me double check if that's the case. Now that you have structure of your transmission decoded, you can calculate the values of the expression it represents. Literal values represented a single number as described of both. The remaining type IDs are more interesting. Okay, we have the one that is simply a value, but we have 0, which is a sum. We have 1, which is a product. We have min, that is with 2, max, that is 3, greater than package, less than, and equal to. Okay, let's see how many inputs they take. Their value is the sum of the values of their subpackages. Okay, if they only have a single subpacket, their value is the value of the subpack. Okay, nice. If we have like some packet that have one subpacket, that will be a literal packet and will be the value of it. Not sure if they can be nested in each other, but let's see the product packets. Their value is the result of multiplying together values of their subpackets. Okay, nice. And single subpackets, their value is the value of the subpackets. And we need to actually execute this. What is equal to packs? Their value is 1 if the values of the first subpacket is equal to the value of the second subpacket, otherwise its value is 0. these packets always have exactly 2 subpackets. Okay, nice. Less than, the value is 1 if the value of the first subpacket is less than the value of the second one, otherwise the value is 0. This subpacket always have only 2, greater is the same, and here min max they work with infinite number. Okay, using these rules you can now work out the value of the outermost packets in your bit transmission. This one, find the sum of 1 and 2, result in 3, etc. Okay, let's go back to our project. We're doing everything in Go. We have input file, we have test file with which we can test this operation one by one, and we have our prompt file in which we save our prompts and answers with ChatGPT gave us, or some other model that we might use, like here in the case we were using in Bing. You can see for some querying some stuff and so on. But let's go to part 2. Let's rename it to, I actually want to rename that, let's be part 2. We remove the copy, our input stayed the same, the test, let's change it to firstly to the one that it's summing 1 and 2, and probably we'll need to do some kind of testing in these cases. And we have one program that is almost working. We needed the initial input program from GPT-4 that we get had some bug here, and we needed to change the index. However, if you watch our previous video, you will know that that's relatively it. However, here when we are evaluating this literal value, we are not considering the number but simply whooping around and so on. Here we need to construct definitely the number in this case, and probably return the value, and continuing with the execution with the value, and simply ignore the version unless there is something very specific for the version. However, for our input we'll continue using the one that we fused here. I mean, was our initial input. Now we need to simply write down that we are happy with that, although there was one mistake. This one needs to be here under, but apart of that, more or less we're happy with the mistake, and we were able to fix the mistake. We're not bothered by. But we need to say, okay, now we have this new requirement. So to say, in part 2, this prompt, let me close all the rest, not to mix prompt and text input with each other. We have this new task. Let me delete everything else. Is this new task that we need to, what do you get if you're evaluating expression represented by your hexadecimal encoded bit transmissions? And our I think it's quite big, because we have the versioning number was 900 something, which showing that it's very involving. Here let's say thank you, your program was accepted. you now move to the next round of the competition. You're given an extension write a modified or Go program that solves the task and read the input from here. Okay, let's see how that will play out. Okay, more or less the hexadecimal bits are staying, or is that okay? I was thinking it's to solve the extended task. We have our bits and so on. At this time we are returning the index, probably int 64, to tell us where we are, and we will probably need to have all this mapping between the possible operation and here already I can see some differences that I'm not. Oh, I'm evaluating. Okay, I can see here we're evaluating the number with this value. We are getting this in 64. Okay, it's actually exactly what I was saying that was missing previously, but now I can see that's not the case. Subpacked, and after that we need to get the recursive calls. Here we will need to get all of these checks for the subpackets values. Okay, we are now checking if we are at the end, and here we have these subpackets values. We need to have this if else condition here. It's this part that it's buggy. We need to remove it. Okay, so far I actually like what I'm seeing. We might need to kind of update it. Let me add it here. I'll ask once again, because I'm not sure if we hit the max token size, but already I think I can see very useful information, or there was something else on top of that was going. What's the main difference so far is that here we're evaluating this part with the number and so on that previously we weren't doing, which is very crucial part. Let me see if this time we'll get any better. If not, even this part, it's already quite helpful. If we, let me grab this part. Talk. I can see that here we have this first part up to here. Now what we were previously, we were returning the version soon. However, that was in this for loop. And so on. We need to do this change up here, and now instead of that we'll need to do the actual, what would we return? The original version, the IDs of these checks. This stuff is fine. Is all of that stuff in the for loop? No. We have the for loop here. And what could we have these results. We're checking now for the type of the values. Here we simply want to continue with checking, okay, with the types of values. I would imagine that we don't. It's simply let me see. If it fails once again, I will say to skip the hex to bit function and focus only on parse packet function, because that's the only one that actually will change. And probably the main function that it's expecting output. Okay, this time I can see that the output changed partly. I can see that GPT-4 he has amazing capabilities, but yeah, definitely I can see that would be nice if we're able to have it faster. In my case, I don't need this hex-to-byte function and so on that it's doing this kind of transformation. We still get the version soon. Okay, that's fine. Not that we need it for something, but yeah, let's not degrade in functionality. Now we're getting all this wrong index swap. We're getting the subversion sum. We're getting the values. Okay, it's obviously will crash with network timeouts. Not skip the which function I don't have. And the main function. Okay, let's see if that will work. Let me add this. Prompt 2. And it's like a prompt 1, but here's this bit here. To simply try to oh man, it's how I'm using the touchpad. I'm not the best with it. Okay, simply ignore all this stuff. There is unfortunately no way probably to get the entire function really being written. We have here the index, probably the sum, and also the new. Okay, we have the version, the index, and the new value. in here we simply continue having these cases with 0, with 1, and so on. I think that's fine. Let's continue with the rest of the bits ourselves, because obviously we're hitting the what's at the moment available with the API as output length and so on, which is absolutely fine. We have a good idea, we have a good part of the stuff that we need. We actually need only this bit here, results, and we simply need to finish that part here by going here. It's already wrong. We have our input. We have here probably the value. Yeah. Here, brilliant. In here, what do we check? Let me write the code myself. We have 0, in which for a result we are simply summing up everything. For product, we multiply of the subpackage, and for that we have 0. For 2 minimum value, we're getting the first one and we're checking, okay, is the result smaller? If it's smaller, we do the value. For max, the next one is 3. Is that the max? Okay. If the value is bigger than the result, we do that. Here, for 4, we're checking, no, for 5. For 5, we're checking, is the greater than packets greater than packets, the value is 1 if the value of the first subpack is greater than the value of the second one. Okay, we have result 0, and we're checking, okay, if the values of the first one we have 1. The value is 1 if the value of the first subfac is greater than the value of the second subfac, otherwise the value is 0. Okay. Six, what we have less than. If it's less than, we have this value. The value is 1 if the value of the first subpacket is less than the second one, and if they're equal, that's in case 7 default no packet ID. Okay, now we have all these packages parsed, we have the result, and in our case we need to return. We need to return version ID result. Is that correct? Version ID value. And our imp, what we want to know at the end, what do you get if you evaluate expression represented by your hexadecimal? Okay, the only thing actually that we are interested here is actual value. We don't care for evaluate okay, and let's give a try with the test. We have this test and we should get 3. And we're running out of band. Okay. No worries. We know this one. It's simply this bug that we used to have here. And we're getting 1. Because we have these sub-values. The sum should be, let's investigate why is the the sub value, not what we would expect. Let me see, that's working. Okay, we're here. Let's jump here. Where what is our type? Is 0. Okay. So I think it's we perform binary search kind of thingy. Okay, we have 1 and 2. All of this stuff looks super legit. We have the version is 6, the index is 40, and the result is 3. Okay, nice. The value is 3. What's wrong with that? Let me do that. We need here D and we here 110. Again, here it's day 16 part 2. Okay, it's 3. This looks working legit. Let's see this 54. 54. The value is 7. Here it's some minimums, because in our final impression 7, okay, working fine. 120, let's be careful and don't rush it. 9, let's see this bad boy. Here it's 1. Okay, produce 1. Here 0. Okay. Zero in this case. Here start getting complicated. 0 and here should be 1. Okay, so far all this stuff looks correct. Input quite big number. Okay, that was day 16 part 2 with the main job done by GPT-4 and simply implementing multiplication and finding the min max element in array. Hope to see you in day 17. Have a nice one.